So I don't lose track of time. If someone could let me know maybe when there's like 10 minutes left or 15 minutes or something like that. Great. Thank you very much. I like talking about this material, so it's easy to get lost in it and then not leave time for questions, and I definitely don't want to do that. So I thought long and hard, and Jenna and I had some really wonderful calls in preparation for this keynote, trying to really think about interesting ideas that I could share with you. So I hope this is interesting, and it tries to bring out kind of a couple of case studies from my work and really highlight some interesting issues that come from working with not only actual social media data, but the platforms itself. So it's a kind of a personal journey in some ways, but I'm going to structure it in the beginning with taking you through some, if you will, theoretical challenges, or how I've been able to surmount some of the things and trying to come up with creative ideas, especially in the context where we have a lot of closed APIs, where we have this sort of black boxed algorithms that Bernhard mentioned yesterday. It's been a tremendous challenge. So I hope it's really useful to you to actually see these pathways and hopefully inspire, or at least stimulate some sort of discussion. So a couple of objectives, which I think are pretty important for what I do in terms of my work more broadly, but things I think that have been very important for me to think about visual social media platforms. First of all, and I know it sounds very trite, but I can't overemphasize this enough. It's really tough to collect data on visual social media platforms. As someone who has spent the bulk of my career collecting text-based data, because that's what social media was originally. So my earliest work looked at blogs and forums, and that was just primarily text-based. I mean, there were images posted there, but a lot of the early computational work I did was trying to collect vast stores of blogs or forum data, run that through machine learning, come out with topic modeling, and kind of go with that. Kind of my journey over time, and having been a scholar of social media now for nearly 20 years, I've seen a dramatic turn towards the use of the visual, with some platforms being completely, not completely visual, but quite dominated by the visual, if not completely visual. I'm thinking here very popular platforms, especially amongst young people, but also across a range of demographics like Snapchat, Instagram, YouTube, Pinterest, etc. In fact, when I speak to my undergraduate students, when I teach undergraduate classes that have to do with data, they often say, Facebook, I don't really do that. I mean, post a couple of things for my parents, but I'm on Snapchat, I'm on other things, and half the platforms I haven't even heard of, but they involve sending pictures. Or if there's a response to something, it's an emoji, or it's kind of a weird snippet of writing on your phone or something. So on the one hand, I built up lots of methods that leverage big data, computational methods, large-scale data mining, data analytics. How do we integrate these big data style collections as well as questions with more in-depth contextualized analysis of this sort of visual social media content? Otherwise, what's going to happen, and I see a cohort of people just sort of saying, well, let's keep doing the text-based computational work, and let's ignore this messy visual stuff. So part of my agenda has been to try to integrate some of these schools of thought, both epistemologically as well as ontologically. So how do we categorize the fact that we have coexistent textual and visual content while addressing issues of ontology? So what I mean here is ontology twofold. One, in the traditional computer science mold of it being taxonomy, of how do we create coding systems, as well as ontology in the more sociological sense of our own identity as researchers. Okay, so for us to be critical and reflexive. So I'm intentionally positing a dual meaning here. And also, how can we scale small data to big data? So kind of my points in my keynote will hang across these four. And the last objective is perennially been a quite challenging one for me, because on the one hand, visual is really is designed to be worked with on a small scale. A lot of visual sociology and visual communication research sometimes just works around one image or two images or three images, which is terribly important. But also in the system of social media research, we want to look at large-scale transfers of images too. It has a different value. For those of you who came to my workshop yesterday on visual social media content, you'll know this is a big thing I've tried to address. So I want to start out with some framing things before I tell you about some of my case studies. So some starting points for you, and the citations are down here. They're not the easiest to read. I'll read them out at the end. But the first comes from Zimmer and Proferes, and this is from Topology of Twitter Research. You can just put that into a search engine, it'll come up. It's 2014. It's fascinating to actually see work like this that tries to do systematic reviews of Twitter research. There's that much Twitter research, as Bernhard mentioned yesterday as well. So 16% of research on Twitter that Zimmer and Proferes surveyed for their systematic research employed sentiment analysis. Okay, so we're text-based. I mean, some of it's shifting to emoji, some of it's shifting to let's rip out images, take sentiment, and do that. But really, this is kind of classic sentiment analysis, sentiment lexicon-based things. Second point, in terms of a starting point for my work around visual social media, has come definitely from Dana Boyd and Crawford's work, and that's Critical Questions for Big Data by Kate Crawford and Dana Boyd in ICS, and that's 2012. And they have famously stated in that piece that there's challenges associated with data collection and analysis on social media, and that's though focused primarily in text-based worlds. I kind of want to recall attention to that as we move into more visual social media platforms. And if you're not interested in the visual, you kind of still have to be interested in the visual. So even if your analysis is primarily text-based, you do have to pay attention to these shifts, is my argument here. Now, traditionally, we have in the realm of coding ontologies and the realm of looking at, let's say we take a basket of tweets and try to gain knowledge or meaning from that, have thought closed coding systems to be best for studying social media. So we go and say, hey, I would like to study Trump tweets on any particular, actually just Trump tweets. I do data collection just on Trump and Twitter. It's depressing. And then I could go in and, of course, this takes a certain epistemological position, say, okay, I'm going to look for this sort of racism or this sort of polarization and this sort of other closed categories. Now, of course, that has value. But what I've seen as time has gone on with this sort of diversity of things, as well as the fact that we have automated actors, so we have bots and other things, is we often we'll find what we're looking for in the social media data. Classic, issue in terms of the scientific method. That's a big fallacy we need to look out for, right? A self-fulfilling prophecy in terms of research. So I have found oftentimes it's really important epistemologically as well as ontologically here that open coding is a really important step. So I'll talk about that as we go along in terms of my keynote. Now, another element that's very important, and I mean, it exists with text-based social media, but it's really true with visual social media data, is we're talking about messy stuff, really messy elements. Okay, not just that we have rough-grained video, for example, a citizen journalist going around on a camera, shakily grabbing stuff after an earthquake, for example, and uploading that. I mean, it's getting better in terms of phones, but still maybe they don't have a lot of bandwidth. They've got to send it lower quality and compress it, or photos were taken around in low light conditions or other things. You could try to pass that to an automated computer vision system like Google Vision or Amazon Vision, but that can also have problems due to quality issues. Or how do you pass a video to computer vision? You can't, right? The best bet with that is extract frames, then pass that. Then how do you correlate the frames together? That's really tough, because frame by frame, you may not have actual themes that would necessarily correlate with computer vision. So even employing pretty advanced visual-based methods that are computational can have challenges. So those were my starting points for how do I actually solve this. And then my head just started hurting. And I realized I've got a problem here. So trained as a sociologist and you know, a kind of researcher in the classic sense, I thought, well, you know, is this a deduction or is this an induction thing that I'm going at? So how do I start this from a classic epistemological perspective? Do I say theoretically this is the theory built around visual analysis? And there's plenty of visual theory out there. Excellent visual theory, then generate my hypotheses around what I think I'll find on Instagram images related to a hurricane, or I do a lot of work in disasters, or cancer-related images I may find on Pinterest, for example. And then I go ahead and collect my data, and then I find some sort of confirmation of the theory, or not a confirmation of the theory. In our world, not only of social media, but in terms of the visual, that doesn't work. Okay, so then we go to an induction. We go Sherlock Holmes on it. I kind of like this image. And we go look at lots of observations around in social media, look for patterns, try to derive some sort of hypothesis, and then we get to theory. That works a bit better, right? But there's lots of problems there. Not only, and it's not the biggest of which, we have API restrictions, we have data outages, right? We have all sorts of differences in terms of the sorts of data that are being presented. So it's harder to find discrete patterns oftentimes. But, and this is the huge thing for me of why inductive methods kind of had real problems. And this goes with some of what I was saying yesterday when I talked about social media research design, is that we have issues in terms of algorithmic bias. Okay? So we have things that are meddling with the patterns that we do not control, that people such as Facebook data scientists control, or data scientists at Twitter, that are meant to optimize revenue, for example. So YouTube page views, as Bernhard talked about yesterday. Then the pattern that we're seeing, we may then come up with hypotheses and generate theory that are all based on an algorithmic intervention. So even though the inductive method looks pretty good, it also has some major problems for me when I'm seeing visual content prioritized or other things. So this is an invisible algorithm that I think has issues. So racked my head, taking more painkillers, I guess, or something, and trying to figure out a solution. The good news is my agony comes to your benefit. And I tried to really go beyond induction and deduction, and have written about this, and I'll give you the citations in a little bit. I also talk about this in my book. So first, there's two methods, and this has come over the last couple of years of developing methods that have drawn from beyond induction and deduction. The first rely on abductive methods, and I know I'm going to classic scientific research methods, and then how do we kind of toy with this, colleagues, you know, in physics and other sciences. We've got great discussions going on in terms of this, but it's really been the way I've reconstructed my research in visual social media. So first of all, in terms of abductive methods, they're defined well by Paul, 1993, and it's from Approaches to Abductive Reasoning and Overview. It states, for finding the best explanations among a set of possible ones. I mean, it's a good alternative approach, right? So we're not absolutely hammering through that we have this hypothesis, we're going to build theory from it. But, you know, what are the best explanations out there? So we're thinking more sideways rather than the hierarchies of induction and deduction. And retroduction, which Olson basically says, is asking why. Why is this happening? And I'm going to introduce some other methods that really rely on abductive and retroductive methods. And one of the great things I find about retroduction, and Olson emphasizes this, is it avoids overgeneralization. One of my big problems with regressive methods, which are terrible for visual social media generally, partially due to algorithmic bias, but partially due to the lack of variables we can often extract. What we're trying to do oftentimes with the visual is search for reasons and causes. So let's say you're looking for a racist image macro that's traversing around the internet, okay? If you want to go through and take observations and patterns, you likely will miss the stuff like the invisible hand of the algorithms or weird effects that are coming through. So I find a retroductive method can be quite good for saying, okay, I want to try to understand how that thing is pinging around different areas, and I'm going to keep my mind kind of open. So Blakey's conclusion is the retroductive researcher, unlike the inductive researcher, has something to look for, right? For me, I think it almost is a sort of questing process that I go on this quest and I don't really know what I'm going to go through and find. So part of my framing here before actually going into how I operationalize this is one that draws from grounded theory, one that draws from a lot of openness, one that tries to break away from standard inductive and deductive logic. So I do plenty of that as well in terms of statistical methods. For visual, I found I've really had to rethink a lot of things I had been doing for many years. I hope that makes sense as kind of a starting point. So I thought, and I decided I wanted to operationalize this in terms of actual methods. For years, I had gone through and had my own systems in terms of if I wanted to collect data from a social media platform, what would I do? This is all fine and good, but then when you operationalize this in terms of, okay, I'm going to go collect data from Instagram or from YouTube or from Snapchat, which is a really challenging domain, but phenomenally interesting, especially if you're dealing with young people. How do you do this? So I came through and I've adapted from grounded theory, and all this I've published on. And the first kind of way I put this together came from trying to think I'd still like to build theory, still like to work empirically with this, still like to use computational approaches where I'm actually going through and doing feature extraction or other thematic reflection. How can I actually build critical, reflective, and conceptual knowledge-based systems here? Okay, so kind of a big task, I guess. Took me a couple of years, but this is the system I've come up with that I've adopted. So in the beginning, I really think about research problems that could be emerging around a corpora of the visual, right? So whether that's a particular video that's gone viral, whether it's a hashtag associated set of images on Instagram, whether it's on Instagram around a particular location, and we've got a centroid with images all around them, whether it's Snapchat conversations between people, how can I deal with this? So same as always, really starting out with the research problem, literature review, and methods evaluation, but using a very iterative approach, which is very popular in grounded theory, but also popular in abductive and retroductive methods. And this draws from Bernhard's notion of technical fieldwork, is to have a first set of field research, and this operationalizes it with tweets, the examples, but you can put it in with anything else, because initially when Twitter and Instagram were linked, you had Instagram images embedded into Twitter. So I would call the Twitter API and collect Instagram posts that way. So I actually have it with having tweets but that's an artifact of like something that ended, I think, in 2011 or so, if I recall correctly. And then what I would do is employ open coding of the tweets, of the users, of the images. Now we have GIFs, other things. So the idea is to actually go through and look at the data. Now, this is a big thing for me, and I operationalize this in an algorithmic way later. I'm really into comparative methods. I mean, I'll introduce a method called QCA later by Charles Reagan from University of California at Irvine. So the idea is this method is constantly comparing the data that you have at hand. And you're trying to get an understanding in terms of the data that you have, and you're iterating. Okay, so the idea here, and it may seem kind of fuzzy, it's supposed to, is if you see certain types of images during your field work in one area of a keyword or one around a constellation in terms of a network, to keep comparing them in terms of your mind. And grounded theory, it works best with keeping notes. I actually use physical notebooks, but you can use, Notepad or Evernote or whatever it is. And the idea then is you start trying to conceptually categorize the aspects, okay? Now, again, this may not seem groundbreaking. Well, at least for me it is. But it kind of is once you start staring at 5,000 images, okay? Because the classic way I've seen students go at this is then say, okay, I've got this data set of 10,000 Instagram images that I'll explain the That's a really hard thing to get 10,000 images from Instagram now. But you could stare at that, and then your eyes will start bulge. And maybe you start with like a random sample of 100, and that's definitely a method. But if you need to actually get through all those images, going through and trying to conceptualize the types of categories that could be emergent there is a hugely useful method. I've done this so many times, and it really works. So then from grounded theory, what I use is a method called axial coding. So what you do is you actually start out with trying to create a code or category, right, that fits a certain pattern that you see emergent. Then what you do with your code, let's say your code, I'll take a case from work I'm currently doing with Hurricane Harvey, has to do with food supplies. Okay? Then you would put codes you think are also similar things. So the idea is they're axially related around them. So it could be such things as flooding, evacuation, right? Emergency preparedness, whatever else. Then while you're going through your other images, you're trying to then come up with conceptual ideas and the properties associated with that. Okay? And then you iterate this. So you're going to go back to a second set of field research and then dig deeper. Okay? So it's not that you're going to look at all 5,000 or 10,000 in one go. You're going to take some of these, you're going to extract feature categories, code around them, then go back to your data and conduct a second field research. Maybe it's looking at other types of images because you missed the mark, right? Or maybe you found something completely different from the images. Like you went in thinking, I'm going to collect things to do with Hurricane Harvey, and these are the research questions I have. You go in, and then you notice, and this was the case actually in our work, that we saw a bunch of images that had to do with Chinese, right? That actually had image macros or comments that were in Cantonese or Mandarin. Then we had to kind of go back and think, well, how do we deal with this? Do we go to Google Translate? Do we bring in researchers that actually have language competencies here? We also saw different themes that emerged. So then we had to go back and think about that. So then the idea here is you can do a second field research iteration, a third field research iteration, and then you can actually build theory and then get to reviews and evaluation. Now, I know this sounds cumbersome, but one thing I want to foreground is it's going to be more and more important, I think, having literacies in coping with visual social media. So I'm talking here about not even just platforms right now, but future-proofing ourselves. So platforms that come up in the future, let's say, that are even more visual. I don't know how we can get even more visual, but we probably will. That this sort of iterative approach is a really strong method to getting through. Does that make sense to everyone? Any questions so far on that? Okay, so this is a kind of big deal for me in terms of how I actually figured it out. And then I take notes the whole way through. And I've been able to get through really large data sets. And I'll explain how this fits with computational approaches as well. So kind of right now, I'm just talking about the qualitative side. But I'll explain later how you can, as part of these field research or part of these iterations, you can use feature extraction of images, et cetera, to help you then try to see where you're going in terms of the content. All right. So I'm going to take you to the first case study of my keynote. And then my second case study is a disaster-related one. So I work in kind of a wide, I kind of work on anything related to social media, but my work has tended to fall under disasters, virtual organizations, including terror organizations, health, and social movements and activism. So those are kind of my areas, and citizen journalism has kind of percolated through various ones of those. So the first case is one of ISIS. It's a research project I've been doing now for about 2 years. Another interesting thing about it is I used Bernhard's YouTube data tools. So for those of you who got inspired by what Bernhard was saying in terms of his toolkit, you'll see it in operation here. I use a set of methods that are fuzzy, so they are based on this kind of idea of trying to be very open-minded and synthesize things. And I go, in this sense, from large-scale data mining. So I'm still using this iterative approach of multiple fieldwork things. But I collect a ton of data through YouTube data tools. And then I take it down to small-scale human coding to try to generalize characteristics. And I'm talking here a lot of data. So I'll explain what I do. And one of the interesting things about this case, besides it being phenomenally traumatic to me, which if any of you watch every single ISIS video produced, you too will go through post-traumatic stress disorder. So I don't tremendously recommend it. But it has this sort of thing is quite fascinating, not the watching of the ISIS videos, but the actual approaches to understanding these sort of content to big data methods is pretty fascinating too to me. So let me take you into this case. I'm going to start you off with, when I did the field work, I didn't go to a particular platform. I tried to understand the visual environment of ISIS across platforms. So I went everywhere from forums and blogs on the dark web to Instagram, to YouTube, all around. So Instagram was one of the first places I started. So this is an example of a post from Instagram. It's actually using axial coding. I would have never, in my wildest imagination, thought that baking and ISIS would actually be a thematic that I would create a code for, but it actually is. It's viewed as a feminist movement within ISIS to create cupcakes and cakes and other things, which connects to baking trends. If you see all the shows about baking and cooking, that they're actually quite skilled in this area, and it becomes a quite powerful thing of propaganda. And then they hashtag it. Right, so I'm not making this up. It really does, and then you can follow those hashtags. So Dawla is, basically an ISIS hashtag, transliterated from Arabic, and then you have cake right there. So it literally translates as ISIS cake, and there's ISIS cupcakes and ISIS birthday cakes and ISIS all sorts of things. And then you have the likes. Now, I discovered this through computational methods, right? So I used sets of keywords to go on Instagram, and I have to caveat this. This is when Instagram had an open API. So I could sit for Kingdom Come and do tons of searches and see where it went. So I couldn't actually replicate this work now with the closed Instagram API. So I'd have hashtag runs that would go on for a while, location-based runs as well. So what I would do is use journalist reports of areas that were reported to have a lot of around the world, a lot of sympathizers to ISIS. I would put centroids in those locations, generally quite large centroids. Then I would collect data and have to parse through all that to actually basically grep it for keywords that were relevant. So I was going through and looking for keyword hits. So on the one hand, I piped it with keywords I thought were relevant, but I only discovered Dawla after a while of going through and actually doing open coding. I realized that these were the hashtags that I needed to look for, especially as not someone as an ISIS supporter. Sorry, is that 10 minutes left? Oh, my time has flown. OK. Holy moly. OK. So it is. All right. Sorry, I thought I had... Yeah, that's what I thought. You completely got the living daylights out of me. I was like, I was going to use Bernhard's line of, I've got so many slides left. I'm like, I've only been talking for 30 minutes. That's fine. I'll sit down. That's OK. Don't worry about it. You freaked me out. Throw the cake at me. It's all good. So give me a second to get back on track. So what I was saying is I used computational methods to find this stuff out, OK? So part of the approach I'm saying is not about necessarily like you have to go onto a space and start taking notes. But some of it, and honestly, I've spoken to a lot of people about this, is about serendipity and patience of going into this sort of data. And I think really interesting stuff can be found in the visual if you're really patient. Now, what you should see immediately from this, besides it being kind of wacky, is it makes for very interesting research within my meta area of ISIS and visual social media, right? So I didn't keep my research question closed. I didn't go through and look for hashtag ISIS, which, by the way, shows you nothing except for content from journalists or people who are trying to do anti-ISIS stuff. You get stuff from like the US government, but you're not in the right wing. The alt-right tweets with ISIS. But people actually in Indonesia or Saudi or other areas aren't doing that. Okay, so part of it is kind of how do you find this sort of content? So I went around these spaces, found content like this. and started developing my research questions from this. So you can see the hashtags very clearly. And then I spent a lot of time looking on Instagram. So I also used network analysis to look at hashtag networks. I looked at people networks. I looked at all sorts of other networks to try to derive things. So the first thing I wanted to say with the approach for framing this sort of work is it really does work, but you have to be really patient. Okay, so one of the big points I'm trying to make here is oftentimes our systems for trying to get data, such as using a hashtag on Twitter, not only do they often backfire on platforms like Twitter in terms of data collection because you're corroding your search terms so strongly, but in the visual, it's even more exponentially harmful to be that closed in terms of how you're searching. Right? So it's really valuable for you to kind of think in these abductive or retroductive ways, keep yourself open and flow, unless you have such a hyper-specific research question, such as, I hypothesize that images found on Instagram within 100 meters of this campus will have positive sentiment, or something, then that, well, you get your data set. You don't really need to use a method like this. It could be a little bit more closed, because you'll just be coding images for positive or negative, and you'll have your coding system in terms of that. So it's not to say that this works for all, or should be used for all visual social media research, but increasingly some of the big questions a lot of you will want to answer, unless you're going that extreme, will need some methods like this that are quite open. All right, so let me take you more into my actual case of using YouTube data. OK, so the first thing I wanted to bring up with this is that ISIS is a really fascinating project in many ways. I mean, it's not for the faint of heart, I'll say, but it's one that I think is good to present to an audience like you guys, because not only is it relatable, but it's definitely one that has had a huge impact in terms of visual social media and continues to do. In fact, a lot of people commenting on ISIS from ISIS have, from a long time, argued how important social media is to their cause and to radicalization. And several people within ISIS, well-placed people, have, via journalists, made the argument that as they lose territory, they doubly or triply invest in social media, because that's their way to get people to conduct suicide attacks, et cetera, especially in Western European countries. So I have this quote that comes from the New York Times. So Western ISIS defector named Ibrahim stated in an interview, a lot of people, when they come, they have a lot of enthusiasm about what they've seen online or what they've seen on YouTube. And I had read this piece, actually, before conducting my research, along with other things as part of my lit review, and it really cottoned on to me. There's something here, but here's the rub, right? If I went to the YouTube API and did a search for ISIS or something, am I actually going to find the content that people such as Ibrahim likely came across? No. But that's what I was interested in, OK? And I knew I had tons of challenges here, because we know YouTube has personalization features. We know of its algorithmic bias. We know that part of it is based on all YouTube searches. Part of it is based on IP address. Part of it is based on cookie history, whether you're signed in on a Google account, all sorts of things. So believe me, I was well aware this was going to be one heck of a project. But what's life without a challenge? So this is where I was starting from, and this is the research question that kind of inspired me for this multi-year project. That YouTube search and recommender algorithms, maybe, this was where I was coming from. I had no idea. I was just through my field work, just through my poking around, positing this. Inadvertently, and it turns out it's kind of true, as the US government poked at Google and Facebook and other things, but at the time, several years ago, I had no idea. Maybe inadvertently directing users to radical content when the user's search is actively seeking radical content, whether they are. So they could be searching for like Syria or Raqqa or something and then come to it. So I also thought at the beginning, we can mine this data, but we can't effectively generalize attributes or causation. Now I want to stop for a second on the causation part, right? It would be very interesting from a knowledge perspective if we could run some sort of regression here and show causality, right? So the only way you're going to do that is to actually get the people who have become jihadis who have now gone to Syria and died, but to retrace their steps, right? And to say, okay, I'm going to actually do questionnaires on these people. Good luck with that, right? And you're not going to get the data from YouTube, right? So you can't say, I'd like to get all this jihadi data from YouTube and actually run some sort of regression. So we have a very partial portrait, and we're making a lot of guesses. In other words, that's why the retroduction, abduction of asking why and posing scenarios, I think is a useful one. So the research question I ultimately came up with is, given that ISIS content is regularly deleted, because that's another thing I was seeing, is it was disappearing, but it was also reappearing in different forms. What types of videos recommend radical videos as part of the recommended video algorithm? So that was the first part. And also, secondly, were there any linguistic or other markers present? And thirdly, what methods can effectively be used for classification? You can see it's a doozy of a research question, right? A nice three-pronged one, one that I knew was going to take a while. But I hope this is fascinating to you guys. And now that I know I have ample time to talk about it, rather than dying and falling over, I can introduce you to this work, which has been very interesting and influential in terms of how I've concluded how to work with visual social media overall. OK, so the methods I used, which I think a lot of you are trying to come to grips with how to work with visual social media, I'm giving you two case studies in this keynote. So this first one is based on multiple mixed methods approaches, and the second one is too, but it deals with Instagram. So after doing this Instagram, poking around, looking up forums, et cetera, I settled on YouTube. And part of it was based on journalists' interviews with jihadis generally who had defected, or they were actually interviewed in Syria and other places, and how they all pretty much said YouTube was key, because it was this very accessible gateway. So once they got one on YouTube, sometimes they'd comment on a video, and then an ISIS fighter would actually connect with them via Skype or Messenger or other things. And there's quite a few cases of this happening. Journalists even went undercover, and this happened to them. So I used news articles which had validated that these were official ISIS videos for 15 videos that were at the time attributed to ISIS's media wing Al-Hayat. Their media wing has changed quite a few times over the years. And then 11 videos were found through searches on YouTube. Okay, so I did this with Google Translate as well. So I would translate to a bunch of different languages. And then I used them as seeds to crawl the YouTube network. Okay, so this was using, and I'll explain this a bit later, but Bernhard's YouTube data tools. And I'll explain how I did that in more detail. And then I constructed a network to represent videos that were recommended, as well as videos recommended by the recommended videos. For those of you who are familiar with network analysis, that's a 2-degree crawl. And then I used a method called qualitative comparative analysis. And that's the work by Charles Reagan, that's R-A-G-I-N, to build a framework for recommending videos. And I'll talk about QCA, I'll talk about the seed network, and I'll talk about how I worked with that network a bit later. But first of all, I just want to show you some of the videos I used as seeds. If you're interested in finding them on YouTube, either good luck or you'll be on a government watch list if you watch all of them. Or maybe you won't, I have no idea. It depends how risky you like to be. So these are the YouTube IDs over there. I haven't gone back and checked these for years, but I know some of them are present again because I have randomly searched for them, and they do reappear. Generally, what happens is they change from English titles to non-English titles. So the YouTube anti-radical censors are really good now at picking up the English titled stuff. They're not so good at the Arabic language stuff. So a lot of it is shifted to Arabic, to Russian, to other languages. I venture to guess Google's probably thinking about using Google Translate for this, but has not yet. So you have some of them like Islamic Caliphate mujahid in English. The mujahid element is actually a really interesting case study of ISIS visual content. They wanted tweet-sized radicalization messages. So they're basically videos that are anywhere between 30 seconds to like a little over a minute, and they move fast. They're done in like fast pans around with quick commentary, very accessible. It looks like people are really happy in the Islamic State. They use a lot of methods of persuasive communication, well packaged, kind of like an infomercial, but what they're selling is ISIS, obviously. Those crop up in a lot of numbers throughout, so I use them as seeds. They were also reported in newspapers regularly. And there's a couple of other ones. Flames of War, for example, is pretty gruesome. Then the end of the Sykes-Picot Agreement are kind of more documentary style. So you'll have an ISIS fighter going around chronicling the Sykes-Picot. Some of them were French language, some of them were Arabic language. Then some of them that got kicked up just weren't found on YouTube, like the clanging of the swords or deterring the hirelings. They had gone more dark. I found them eventually, but they weren't on YouTube. So that sort of content was what I used as a seed network. So then what I did from this is built a two-degree network using YouTube data tools. So for those of you who are interested in replicating this sort of research, or if you wanted to replicate exactly this research, though you'd get different data, you go to Bernhard's Politics of Systems website, you navigate to YouTube data tools, and then you enter the YouTube video ID. So in this case, they're the ones to the left. And on YouTube, it's just the end of the YouTube URL. Okay? Then you can select within YouTube data tools how many degrees out you want it to crawl. For any of you who have done this on YouTube data tools, not only will you find, and it's nothing to do with Bernhard, I mean, it's an excellent tool, it's just everything to do that. If you're running it via his server rather than your own iteration, so my tip to you now is, if you're doing a big data pull like this, you may want to run it on your own machine. It takes a long time to collect this sort of data, and then it often times out and crashes, then you lose your data. So if you are going to do it on his server, just be very patient. It does work in the end. So I basically came up with a network of using all the videos as seeds, and then coming up with 190,087 edges and 15K nodes in this. So it's pretty big and hard to go through, with the naked eye. Partially just because I'm a sucker for punishment, I used Gephi rather than Payak to do this. Partially because I wanted to see what Gephi would throw up from visual exploration, but knowing that memory-wise, it was going to have a challenge with this, which it did. For those of you who have done 200K nodes in Gephi, sometimes, meh. I hear the newer versions of Gephi are doing a lot better with these sizes, so I may play with these data sets in there. But I did do it in Gephi, so it's proof that kind of an accessible way of collecting it. So part of this project was also to use an accessible way so I could replicate it in teaching as well as other research. So I'm using data tools on Bernhard's server and then using Gephi, all accessible freeware, and able to conduct a research project that I think worked well. Okay, so going back before I actually get to results, I want to take you a little bit more into the world of algorithms. So one of the first things I noticed in this project was how important it is to understand, I mean, as an engineer, I understand algorithms, but how important to critically understand algorithms to conducting this sort of work. I know this is an undercurrent of my keynote talk, and it's intentionally an undercurrent. So try not to be one of those people that just goes and collects a bunch of images or videos, but understands that you are getting seriously biased data from the get-go. Okay? And this data pool is seriously biased data. When I take you to the actual method of analysis, you'll know that it came from the fact that I knew I had collected biased data. It's a seed network. It's biased by virtue of that. If I had every single YouTube video out there and the whole network, then it's not a biased data sample. So I'm starting with a biased data sample. I can run correlations, which I did, but those correlations are already biased. I cannot run regressions unless I'm a complete idiot. So I'm dealing with this weird data set that's kind of fascinating, but still messed up and biased. How do I deal with that? Well, then I had another layer saying, I've got biased YouTube algorithms. So in terms of my research question, I really kind of hummed and hawed about how to deal with this. So the first thing I saw actually in my fieldwork when I was going through and typing in search terms, so one thing I did in the technical fieldwork elements is I was typing in search terms to see if I could get to those videos. Because if you did try this at home, what you'll find is generally typing those video titles won't get you them because they've been deleted anyway. So if you want to get to them, they're a little harder to get to, okay? But then what I found it out is obviously people were getting to that content, so how did they get there? So one of the things I noticed is the recommended boxes are used by a lot of people. So in other work I've done on, of all things, health, I noticed that people who are watching health videos generally went to the next video that YouTube recommended. They just kind of binge watch health videos because they had a particular condition they were trying to learn about or they wanted to exercise. So they just kind of go down the rabbit hole and they'd be like, okay, I'm really into Pilates and I'll watch all these Pilates videos. Or I'm really into yoga, I'll watch all these yoga. Or I'm really into like, big heavyweight weight training or whatever. I'll watch all these videos, okay? So I kind of theorized that this might be happening with people who are becoming radicalized, though I don't know any of them, so I have no idea. Again, just a hypothesis. But, and this is a big but, that recommended content is part of YouTube's algorithmic black box, right? So I don't actually know how I kind of know how the algorithm works, but not really. Like what percentage is it of this factor, of this factor, of this factor, of this factor that makes something recommended? Now, we know it has something to do with location. It has something to do with whether you're logged into to Google. It has something to do with what other people have done. So the best we can do here is try to reverse engineer what could be happening, because we don't have access to YouTube's proprietary search data. So ultimately, and this is a big problem if we're actually asking a question like this, and a lot of visual content we're trying to deal with still falls under these same parameters. Like if you go through on Instagram and collect hashtag Lisbon, you're not going to get every single Instagram image that contains Lisbon. You don't even know what fraction you're getting. It's not like Twitter where you're guaranteed 1%, not on a keyword, but on Spritzer. So you really have no idea what that data is, right? That's something I really want to underscore again. Like, be transparent about that, something I emphasized yesterday, but be very aware you've got like I have no idea where this data came from data sample that is just messed up. It still has value, but we have to figure out innovative methods to make value. Otherwise, we're reinscribing bias and claiming there's no bias in the data, which is deeply problematic to me. So we don't know what percentage of users, in my case, explicitly search for ISIS content versus accidental exposure. There could be someone really trying to like radicalize, and there could be someone just going, I'm interested in US politics in Syria or something. And then they're accidentally exposed, and then they actually end up being interested in this and sympathizing. So let me bring you into the results of the first case study. So I've got time to talk about the second case study. So the results. I'll first show you some things that came from my technical fieldwork by means of results. And then I'm going to introduce you to a method that's QCA, which is a comparative method. It relies on Boolean algebra. Okay, so what that does is, how many of you are familiar with Boolean variables? Show of hands so I know. Okay, so I'll start on the basics of when I talk about Boolean approaches. They're basically whether you have conditions that are conjunctive, so something and something, or something or something, or something not something. But I'll introduce that in more detail. All right, so first of all, stuff for my technical fieldwork. So I was going around, and you can see actually typing, I mean, you can't read what it says there, but I was typing in keywords. I used, for complete transparency here, Tor networks. So I used Tor-enabled browsers. So I had no search history embedded within the reset all their sessions. They're going from different IP addresses. So I'd be bounced to Google Norway or Google Russia or wherever, all sorts of places before I went here. So when doing this, I was able to replicate, though they would be in different orders, ISIS videos as recommended videos. Sometimes they were in the first ones. Sometimes they were later ones. So you can see here, that's a Mujahtweets one, for example. That's also a Mujahtweets one. These are all in Arabic. But it's actually, the video is British jihadi taunts the West. We will kill every soldier you send. And it's by a news site. Okay, so it's actually a news site that's not a radical video. It's just reporting. So if someone was watching this news clip, they'd actually be recommended to these videos. So I found this when I was actually in my fieldwork point. But this is obviously kind of small data at this point. If I'm poking around, I'm making notations that there is recommendation happening and that people potentially could be doing this. How do we combine the big data that I collected on the seed network with this sort of thing? Okay. I found that a real big challenge to get to. That's the part where you cannot just take your downloaded data from data tools and be able to do that. So I had to write and this is one of the few times I went into Python and started writing my own code, but went through and actually developed some code to do some matching to figure out what could be happening here. So some of the results, and one of the first steps I did was using network analysis, since I'm a big network analysis person, was insert attributes into my Gephi file. So I took it from, most of you, especially if you worked with a tool like Netlytic, will derive your network file as a GEXF data format. So one of the interesting things you may want to think about doing if you want to mess with your own data files is to take it to a GDF file. So that's basically a more CSV accessible format. So then you can run that through Python or other scripting and modify it. So that's what I did. And then I went through and ripped out, and I'll explain the slide in a second, things that were in Arabic, okay, put that to the Google Translate API, and had them return English translations. So that was the first thing I did, so that I had access to all these videos, assuming Google Translate was OK with Arabic translation, which I showed it to a friend, and they said it was pretty good. I was able to also code edges by colors, if they were official videos or not. So one of the other things I did using Python was go through and create a dictionary, if you will, of official videos beyond the seed videos to then reclassify edges that could be considered official videos. So I kind of knew whether it was a kind of news report or something else, recommending to radical or the other way around. Because really, at the end of the day, if you're at radical content and you're being recommended other radical content, it's maybe not such a big deal as if you're going to innocent content, so to speak, or non-radical content being directed the other way. So I found these clusters. So they're little clusters that are around the network that basically have videos, and they tend to be, as you can see in the case, that black nodes represent official videos. And then we would see those kind of go. There weren't that many instances, actually, of the other way around, where you have non-radical content going that way. But there were some instances. So I was able to then go from this huge amount of data with some of this manual stuff and then focus in on nodes where we could be going the other way, as well as looking at nodes of going that way. So I was able to go from all those edges and then stream it down quite a bit. So that was a really important kind of first pass in terms of going through things. And I also found that there were definitely networks around Arabic videos that were still able to persist on YouTube. And I replicated this study a couple of times as well, and then saw even though English was being more and more kind of aggressively targeted, stuff in other languages, not just Arabic, there were a couple of other languages that came up as well, would kind of exist like that. And then one of the interesting things with the YouTube Google API, and again, this is largely computational, it's hit and miss, is they do have genre categories. So one of the things I was able to do, again, knowing the data was biased, but use SPSS, you could use R just as easily, to then go through and do visualizations of all the distribution of if they were a radical video, what genre were they classified at, how new were they, what was the age, how many comments did they have, how many likes, etc. So there's a lot of work you can do within the visual also that's not necessarily visual, but that will use formal descriptive statistics and other methods some of you are already trained in. Okay, so the first part of this question was regarding linguistic, cultural, or other attributes recommending videos had. Now this is where I got into a real tough bind, and I'll confess what I did, why it didn't work, and why I had to change it. So I first started using correlation methods to do this. I thought I could pull it off, even though it's a biased sample, right? I thought I could just take the attributes derived both from the YouTube API as well as manually coded attributes and run correlation, and then go ahead and see. Okay? And I went through and ran it. It's easy enough to run, right? But I realized very quickly, not only myself, but with speaking with colleagues, that I was just completely off the mark. I was completely aware of the algorithmic bias, but it didn't occur to me that that algorithmic bias would mean that the correlations were totally useless. Okay, because it's all well and good, it all looks fine, it's all statistically robust, but how can I actually claim anything about the attributes of these videos via correlation and provide a p-value with this level of bias and having no idea what the user search patterns were or what was being returned by the YouTube API, right? So I just threw that out. I just used it kind of as this completely knowing this is just a thing of description. I'm not claiming any knowledge. It was part of my process of getting there. I've retained it in some of my writing, but I wasn't able to conclude anything. So I went and presented the paper a couple of times and kind of opened it to the audience saying, yeah, I don't really know what to do here. And I had a couple of people mention QCA to me and say, you should try this out. It could work. It's mixed. I'd heard of it before, but never used it. So for those of you who are unfamiliar with it, it's a method that's taught at, by some methods teachers, especially in sociology. And it hasn't been used that much in social media, but I'd like to make a plug for it, especially in visual settings. I think it's really useful. So you can look it up. There's a lot of tutorials. Reagan, it's Charles Reagan, R-A-G-I-N, developed it. There's a piece of software as well called FS/QCA. It does have a GUI on it, so it is visual, but you do have to be patient with it. It's not a bells and whistles product like Gephi. So what QCA tries to do is uses the comparative method for making best guesses. So unlike regression models where all the variables are in a race to see which can explain everything the most, QCA does see which variables can explain things the most in terms of attributes and outcomes. So my outcome variable is the video a radical ISIS video? Okay? And I'm trying to see what attributes in my network would have the attribute also, would have the outcome variable about recommending one of these videos, a radical video, or being a radical video. So what I did in terms of QCA is leverage the fact that it uses Boolean algebra for attributes. So what that means is it is going through and in its algorithm, which is pretty transparent algorithm in many ways, is looking for if two things combined or multiple things combined. So those are AND statements, best explain an outcome, or if it's AND and not, or ANDs and ORs. So are there variables that are conjunctive, minused out, and ORed? And you can have all those things existing together. So it could be A plus B, not C, or D, right? Some sort of Boolean algebraic equation like that. That's basically what it's doing, comparing. It's kind of like our manual human comparison, but you're going through and having to then manually code attributes, all right, for each video or image. Now, this is please pay attention on this. So this is a method then that I have developed now that transfers well. It's not just a YouTube thing. So any type of visual content, it works well for. Now, if you're a trained qualitative researcher in terms of images and you do close image analysis, great, and that works for you, excellent. But if you're dealing with a large corpora and you want to systematize it and you want to get through 5,000 images or 1,000 or 500 even, you kind of have to go to something more systematic like this. So then what I did is developed, and this wasn't a closed code book from the beginning. I used open coding, went through Instagram, had all my notebooks, and basically developed 11 attributes that we coded for all the videos that were randomly sampled from the network. So we went through, we coded things like language, whether it was a news program, whether it was an official ISIS video, obviously, whether it had a particular polemic political agenda, whether it was sympathetic to ISIS, whether it wasn't, those sort of things. And then we this again was a process. So what I first did was go through and did that for the seed network. Okay, that doesn't really do much. Then I did it with some random sample of like data within the network. Okay, that's there. And then this was the turning point. Okay, so I realized I still had a problem there. And again, this method can be deployed with Instagram images, with Pinterest images, with all sorts of images that you're trying to do something that you'd want to regress or explain some sort of causation in terms of particular outcomes, right? So this was the magic moment for me. I realized I actually needed to randomly sample YouTube. Okay, so a kind of controlled environment. So we're thinking kind of like normal statistics in that way. So then I did a random sample of videos from YouTube. Of course, there was a cat video in there. So you can basically use random number generators. The same thing, it randomly generates YouTube IDs, because YouTube IDs have a certain amount of characters, whatever. And then what happens is some of them are non-existent videos, some of them are. So you just have to either have like a line of script that checks that they're a valid YouTube video, or you do it manually. So then I did a bank of these and added them in. So I have official ISIS videos that recommend ISIS content. These aren't the seed videos. They're ones that actually, in my network analysis, in that Gephi network's SNA network, an official ISIS video that recommends ISIS content, that's one. So every single video that recommended an ISIS video, whether that was radical or not, was included in my sample. Okay? Then videos that did not recommend ISIS videos, a random sample of that, and then a random sample of videos from YouTube. And then I put this through and coded 11 attributes for that set of videos. Does that make sense? So there's a kind of systematic approach. I feel this worked well because it reduced bias. And at the same time, I was saying I was working with a biased data set, so I was trying to make it generalizable by collecting from YouTube, by collecting everything. So I feel that this sort of method works well for us to have a higher power of generalizability. So I feel that this is a generalizable set of characteristics that we're able to go through. Now, one of the things with QCA is it's not a one-click process. So unlike a correlation where you'd go through and dump in all your variables and get p-values that get spit out in a big, large correlation table, QCA is not your man for this sort of thing. So it's also iterative. You'll go through, you'll select different things that you think could be possible explanatory things. It's a kind of qualitative thing in that way. As the QCA operator, you need to actually be familiar with your data. That was a really interesting thing about this method. You can't just, as in a regression, send your data set off to someone else and say, hey, can you make sure that I did this multilinear regression okay? You've got to actually know what your data is, because QCA could be saying something could be attributable, but it may actually be an outliner or non-explanatory. So you're using your experience with the data to then go through and put things in and use FSQCA's algorithm to help the Boolean algebra basically add possible explanations. So this is why it's retroductive or abductive, because it's giving you possible explanations you may not have seen, but you as the human ultimately are seeing if those make sense, and if not, you generate new ones. It's almost kind of throwing out possibilities based on Boolean algebra, so they're not out of nowhere, right? But it's not definitively saying with the p-value, this is what's happening. Now, with a biased data set like we get in social media, this is magic, because you're not claiming huge generalizability with a statistical p-value. You're claiming, I think this could be explaining why these videos are being recommended on YouTube, right? Turns out that is what's happening, but it takes a long time to get to that. And then you can go back and validate that by actually typing in things and seeing, all right, are these the attributes that match up? And you can actually go through and verify it. So a human in the loop needs to be there. One of the cool things about QCA and the FS variant is that the FS stands for fuzzy set. So you don't have to necessarily have closed coding where you go through and close all the attributes to be, is this an Arabic language video? Yes, no. You can also have a spectrum of like 1 to 10, kind of like a Likert scale of like a sentiment value between happy and sad or something else. And you can go through and do that. So what happens when I did all this is I went through and generated a bunch of these tables as possible explanations. And I landed up with this. and output. So it gives you a nice output, and you can see the Boolean operators here as well. So first of all, you have radical keyword. So if the title of a YouTube video mentioned a keyword from a radical ISIS video, one of the actual ones, 34%, so the 34.6939% of the videos that were recommended in this sense had that keyword. Okay, so radical videos were recommending basically videos were recommending radical videos if that video contained one of the keywords 34.69% of the time. So if you had a news report that had one or two keywords from radical video, that actually was how those instances got explained that way, which kind of makes sense, but it's kind of shocking, right? Like, why the heck was Google letting that through? That's like the easiest thing to protect against, but they didn't. And then all these other combinations, right, added together made a set of 69%. So these are a lot smaller. 28% is explained by if the video was a newscast by an organization, was in English, and was recent. Okay, so that's an and. If all four of those variables take place, then we can add another 28%. All these are a lot smaller, right? 4%, 6%, 6%. But if those things are all put together, we then have a model, right? It's not like a regression model, but it's a set of attributes we can then go to and argue. So my research found in many ways that even though visual social media is really hard to work with, there's a lot of possibilities when we have a mixed method approach like this. We can scale it up, and we can really connect the two synergistically in lots of ways, which I think's been a pretty interesting journey in lots of ways. So I'm going to take you to my second case study briefly. It's not as complex as this one in lots of ways, so I can do it in a briefer time. It also then hopefully will connect the dots that I've laid in terms of abductive, retroductive, and some of the challenges. So Instagram and disasters is my next case study. So I'm going to talk about the fact that one of the major limitations of visual social media data is our inability to accurately interpret tons of it coming out. Okay? So one of the other areas I work in is when a disaster strikes, people are going on social media. They're posting what's happening to them in the moment. Right? I'm in this earthquake, I'm in this flood, I'm in this hurricane, I'm in this tsunami. We have the same problem with algorithms, okay? Even though the algorithms are trying to be deployed to then decipher what images are relevant to people trying to fix the gas, the water, rescue people, it doesn't quite work, okay? On the other hand, also, it would be maybe fallacious for us to let the algorithms decide who needs help, or maybe not. Okay? Should an algorithm actually then try to pick out from social media streams like what's happening here? All right, so one of the first things that's really interesting here, and it's probably something you guys have thought about, is a lot of visual social media data I consider to be perishable. Okay? You're not going to get it back again. So this is a really tricky thing. I mean, it's true also of tweets and other things, but there's historical search with a lot of things. I mean, Instagram has some historical search as well. It's one of the better platforms for historical, as Jenna talked about yesterday. But it's still really hard. Like in an earthquake, okay, you have soil liquefaction, buildings could fall down, and then you may not see those images because when you search, you're only shown kind of the current stuff. So one of the things you really need in this are agile methods to collect that data. So if you've done work like I've done in the first part, you then have a toolkit that you can deploy quickly. You can take your time to code the stuff, but you need to oftentimes quickly collect the data. So one of the other plugs I want to make now is hopefully at this data sprint you gain skills for whatever platforms you're interested in collecting, whether it's using Bernhard's tools or Netlytic or whatever else, so that if something happens and you think the data is going to be perishable, collect it. Don't think just collect it. That's not to say be data driven, but you should collect the data, and then once you think about your methods, at least you have access to that. Otherwise, you probably have to pay for it. So it's perishable. And oftentimes, visual social media data in disasters isn't collected because it's harder to collect as well. So it's just let's collect the stuff around hashtag terremoto or whatever, and then we'll collect that. And that's actually a terrible hashtag to collect around most of the time. I tried it with the Mexico earthquake just for curiosity, but there's other ways to get better data. So because many forms of traditional social media data harvesting really aren't focused around the visual, they become perishable. So when we extract JSON from most social media platforms, we just get the URL information of embedded images. Now, a couple of problems. Instagram doesn't allow you to scrape those URLs anymore, right? It depends if you want to follow US law or not. But under US law, you cannot go collect Instagram images by any scraping, mining, automated means. The only thing that's allowable via the terms of service is to take a screenshot, right? You can do what you want with the screenshot, but that has to be taken by hand as well. You can't use screenshotting software. You actually have to click on the thing. So what do you do during a disaster? Start going through and screenshotting till your arms fall off? Yeah, basically with Instagram. There's no other solution. If you guys come up with something, let me know. It's that silly, but it's also that perishable because that stuff will disappear. Not only, and this is what I'm saying, if you go through back and search for those keywords a day later, you may not find those images, okay? Because how does Instagram's search API work? I have no idea, right? So you literally are sitting there going and trying to, so that's one thing I'll say. This perishability was the reason why I wanted to briefly share this case studies. That's one of the biggest things I learned, is then when a disaster happens, I literally will get everyone I can in my research team collecting data. We'll just all go and collect it however we can and manually get it. So the first thing I want to say with a lot of visual data, YouTube included, is this stuff disappears, it's perishable. What you get returned via search changes, the comments that you get on a YouTube video change, all this stuff's just very changeable. So try to be very agile if you get interested in this. That's not to say you have to, but you can generally answer more if you've got more robust data. And the stuff doesn't always persist, okay? So Facebook, Twitter, et cetera, Instagram, these are, all these things suffer from this perishability. Now, one of the ways in which we can it's not to deal with the perishability problem, but it's to deal with the fact that we start getting all this data, right? And I talked about the very clean, elegant, multi-step, iterative approach. Now, one of the ways you can integrate that approach when you have all these gobs of weird data that have come in, through all your screenshotting, through all your collection of YouTube comments via Netlytic or data tools or whatever, is to use some computational methods. So one of the other things I've employed is to basically extract out content and do it. That's something to do, right? With comments, you can use things like LDA. I've done this. But machine vision is pretty bad in terms of dealing with images and the features that are there, right? If you pass a bunch of images that you collect around a racist demonstration, for example, it's generally going to just tell you the basics about something. So, what do you do with that? Well, one of the things, I want to make an argument about here is the diversity of content, and I've done this in quite a few studies, is extremely challenging for machine learning systems. So one of the other pitches I want to make here, besides the perishability thing of visual social media data, is that it's really worth your while to work with what are called hard data. So this comes from Burgess and Brune's piece, Easy Data, Hard Data. And it's a really great piece. And what they say is that rather than running straight to the problem and trying to solve it, and trying to pull that data, we have to really think about how we can enrich that data, how we can push through it, how we can get the most out of it. So things such as what I've done in that first project of trying to really ask deep questions, get us to that harder data. Machine-driven methods, I think, are quite useful for sometimes finding big meta-level patterns, but I think oftentimes we have to invest more in terms of qualitative methods to get there. Also another problem, and I love these little robot picture things, is we often, if we just do computational methods, we often don't have a human in the loop with visual projects. So it's tempting to take, let's say, 10,000 images that you get. Let's say you screenshotted all these things from Instagram, and merely, I'm not saying you shouldn't do this, and merely give them to Google Cloud Vision API. Extract all the features in JSON and summarize that using descriptive frequency statistics. Right? You can get that published in some journals, I'm sure, and conference proceedings. I think we're giving too much into the algorithm at that point. Because if I'm banging on about how bad black box algorithms are, and then I recommend you guys to use Cloud Vision, that's another black boxed algorithm. Not saying you can't use it. It's good at things. Like, I mean, my favorite use of Google Cloud Vision is its reading of text. It's phenomenally good at OCR, optical character recognition. But could this be leaving us with a crisis in crisis data, right? Like data I'm getting from disasters. And I think this could be a problem. So one of the things I've worked a lot with in terms of images, because I'm not trained as a visual sociologist or a visual person, but I've been someone deeply committed to studying social media and seeing these shifts, is I spent a lot of time on motif-based analyses. So another thing I want to pitch is, even if you're not trained in visual methods, such as the nuance of image, which of course has wonderful impacts in terms of research, is you can do a lot of work with motif-based analyses. So those are classifying images based on genre. Right? Is this a picture of food? Is this a picture of that? It's basically assigning attributes to images, right? But a lot of effort is required, okay? So I love this method. I absolutely love this method of going through. It's not the most expert or complex to go through and say an image is X, an image is Y, an image is Z, and go through 11 variables or 20 variables or 30 variables. However, multiply that out and scale that. That doesn't scale to big data. Okay, but I want to make an argument here, and it's a good one, that with 1,000 images that are randomly sampled from, let's say, 10,000 or 15,000. So let's say you're that person that screenshotted 15,000 Instagrams, and you took a truly random sample, again from that biased data collection, but you did a random sample of 1,000 or 1,500, right, and did that across 10 attributes and went through and coded it. That's, I think, a robust method, right? That's still a lot of images that accounts for different things, maybe different time periods, maybe different platforms. I have no idea. And if you do them with two coders, right, so not just yourself, but you and someone else, it's not necessarily easy to do that because you guys have to agree some coding mechanism. And then you run intercoder reliability, it's even better. Okay, so I'm making a package here of a mixed method where I've used some sort of API-based pull, maybe even some computational methods like Google Vision to come up with my research question. So maybe Google identifies some theme in the 15,000. That informs my research question, but I don't let Google Vision actually do the coding of the images. I've just used it to give me some top-level data, or 100,000, or 1,000,000 images, and you just can't get through that. Then I've got my sample of 100,000, 15,000, 30,000, take my random sample, and then human code. It's the same thing I've done with tweets, text-based tweets. Same thing I've done with YouTube videos. Same thing I've done with lots of things. So even though you're not dealing with a huge number, statistically, those sampling rates are beyond OK. In fact, the literature says you could take 100 or 150 and still generalize, though I recommend higher n values. So there's a kind of cool thing you can do in terms of this mixed method, qualitative, quantitative, computational, that then can get to analyzing the visual in much more deep ways. So I'm arguing for thematic coding, but maybe thematic coding across several attributes per image. Even if you just did a single image, and I'll show you the results of that, there's quite a lot that you can draw in terms of that. Okay, so even if you just coded every image for one thing, like what category it is, you can actually make a lot of interesting arguments of that. Okay? In fact, what you can also do is once you code those images, you can look at their distributions, right? So you could say, for example, do particular categories follow a power law curve in terms of distribution, right? So do you have a bunch here and then have this sort of long tail with other ones kind of going out with two categories bursting at the top? So there's really interesting stuff with this sort of image-based classification. So let me quickly take you through my results, which have been published. So the piece that this is published in is Visual Social Media and Big Data. that was published in 2016. And the other studies I mentioned, the easiest way to get at them is to go to my website. So it's dhirajmurthy.com/about. Okay, so it's just dhirajmurthy.com/about. And then there you'll see the ontology of tweets, which is my coding mechanism for the last one. And the ISIS paper is unpublished right now. So what I did in this piece with my colleagues is we looked at Instagram images, but they were posted on Twitter. So this is why that framework mentions tweets, because I developed it when Instagram and Twitter were friends before they parted ways, quite non-amicably. So we got all these pictures from Instagram, and now Instagram doesn't have automatic scraping. So I couldn't do this again. So this was unique to the time in having all these Instagram images. So now if you wanted to replicate this, you would have to go to Instagram or go to Twitter. And well, Twitter you can grab images, but people don't post images on Twitter the same way during disasters that they do on Instagram and Facebook. That's another thing to know. The type of visual content you get on Twitter, even though it's easy to get visual content, is totally different and usually not even close to as good as Facebook and Instagram. Facebook is honestly, it's way better than Instagram, right? So our current work with Harvey, we're primarily looking at private Facebook data from respondents that we use qualitative interviews. So we actually interview them, and then we get screenshots of their Facebook, et cetera. So we're talking about a lot of situations where you don't have automatic scraping, so you're already thinking in qualitative or more difficult ways. So we studied Instagram during 2012 Hurricane Sandy. We looked at a 2-week timeline surrounding the day of US landfall. So it start basically before it hit landfall, and then afterwards. And I wasn't just making up the numbers before what I was thinking of. This was a project based on nearly 12,000 images. We coded every single one of those. Okay? So, but I'll explain, we did not code them for 10 attributes. We coded very simply in terms of what they are, just a couple of attributes. And all of this done by hand by multicoder. Okay? So it's something that works. It takes time, but we're able to, I think, make a lot of important conclusions about Sandy. And I did 2 pieces on Sandy. So with this data, basically, we went through, took these images. The images were basically collected from 142,000 tweets. Okay? And this was back in the days when people actually geotagged things. So we actually could go location specific. Another piece of work that me and my collaborator and I did, sorry, my grammar's terrible right now, then also geolocated by city. So these Instagram photos that were embedded in tweets, we coded them into categories. So basically what we did is we did motif-based coding for the images. So we were trying to see if the images were related to categories like food, relief, people, external environmental damage, all those sorts of things. So the idea was, how can we take all these 11,964 images and give them meaning, right? So this is not rocket science in terms of diving into each image, because really like 12,000 images, if you're going to do some narrative analysis of that, that's like a lifetime project. So images that fit multiple codes, so we did say that it could be multiple things. So it could be food and relief and people, okay, had like double coding. So we could actually code multiple times. So from those 11,964 photos, we came up with 15,985 instances of codes. Okay, so those were all the coded categories we basically had that came through. Then what I used, and in the actual paper, you'll see we used R to kind of go through and show plots of all these things. Actually use some big kind of scatter plots and things in there. I'll spare you that on this slide. So on the simple side, this is what we kind of came up with in terms of examples, right? So this allowed me to take really complex stuff, and this was pre-Google Vision, right? We had collected this data in 2012, started work on this in 2012, and took about 3 years to do this work, because that's a lot of images to parse through, to code, to validate, to make sure we were barking down the right path. So we have examples of damage. We have examples of things that had happened outside, examples of people, examples of food, examples of drink, shopping, relief, macro images, right? When you have overlays of text, macro text, advertisements, animals, screenshots, which actually happen a ton now. So in my Harvard research, I've seen screenshots are a really big deal of stuff. And gear for preparation. Okay? So this allowed us to get some sort of typology of how people were experiencing Harvey. And what we did is a really interesting method I found, and I pretty much have deployed it on most of my visual work. In fact, a lot of my work are temporal variables. One of the great things about social media is you have time and date stamps. Some platforms actually let you see the EXIF data on the pictures to see when the picture was actually taken, but platforms like Instagram strip that out. So we know when they were posted, but we can put this on a timeline. So part of the work that we did also plots out images, and we use sample images too, and we put them by time. So we say these are like a random sample of the images from this time, which happens pre-Sandy's landfall. So you have stuff like food, people partying, like that's a lot of people in New York just went and got completely drunk, had big meals before Sandy because they actually didn't know what was going to happen. And they thought, hey, if we're going to completely lose power and everything goes wrong and New York floods, let's do it with a bang. Happens a lot with disaster studies. Getting of gear, the empty shelves of shopping, these sort of things come up. But it was really interesting also to see things we hadn't expected. So this ad right here is an ad from American Apparel, the clothing retailer. And they say, in case you're bored during the storm, 20% off everything for the next 36 hours. I mean, wow. Like, we were shocked, right? But that came through the fact that we didn't use any automated means. We went through and like looked at this stuff and coded it. So we saw it right when it came because we went bang. Whereas if it went through Google Vision, I mean, that you could probably get some of that, but it's harder to find those things. So part of the pitch I'm making is you could write a whole article about that one thing going, wow, like, you know, even like, and that's how we're finding that happening more now with bots, that they'll go in during a hashtag and do it during a disaster or a geolocated area and try to sell things to people. It's pretty sad and devastating, but us humans are that way. Okay, so some flashpoints to this sort of crisis I experienced in studying crises. I know that's very cheesy, but a couple of things. And you can see it actually with the boxes. And I don't know the conclusion to this. Is, you know, this is public social media. Do you include people's faces in it? I've toyed around, so sometimes I have, sometimes I haven't. So what are the copyright issues? What are the ethics? Are these vulnerable populations since they're affected by the disaster? Or are New Yorkers not really vulnerable? I don't know. These are kind of flashpoints I think about in visual research. Because it's one thing to publish someone's tweet that you may find a little vulnerable, but Twitter kind of says, well, they published it on Twitter, it's published. Again, it's a big ethical, you know, consideration, but with visual, it's even harder. So some countries, and one thing I want to say with visual research is, be very mindful of your own country's regulations, as well as European regulations and US regulations. So the US is one of the most permissive, right, under fair use protocols. But countries like the UK, for example, are really, really, to use a very English word here, pernickety about copyright, right? They're very particular. So some journals actually will require you to have permission from the person posting the image if you include it in your article. Okay, so I will kind of foreground that. So another thing to think about in publishing this stuff is copyright issues. When you're dealing with it, it may be one thing to collect it, analyze it on your computer, aggregate it, do statistical tests or frequencies or other things. But if you actually want to post samples, can you do it? Okay, so that's something that we found very interesting in speaking to journals. There's also something to think about, and the data sprint hopefully is helpful to you, is oftentimes people have a lack of computational skills for doing this sort of data collection. So this pull was using custom Python for us to do our scraping. And now, you know, with Instagram out, well, you don't need computational skills. You just need a heck of a lot of patience in screenshotting. But then other platforms, let's say you wanted to go to YouTube, you wanted to extract videos, and extract frames of videos at randomly sampled times, that's kind of hard. So we do stuff like that, and with the ISIS project, I'm doing things like that. But that's kind of hard. So you need to think about some of the skills you would need, and then getting those skills if that's something interesting. Data access, Instagram's a perfect case for that, but there's tons of other platforms where we either don't have the view counts or what's happened, and also data costs. So if you want to actually get this data now from Instagram, you have to pay for it. So if you wanted to get all the Sandy images, you could get them, I'm sure, from Instagram through a third-party retailer, but you'd have to pay for it. The other thing that we really discovered is time limitations, right? So dealing with 12,000 images or 20,000 images, even with random samples, takes time. So these are projects where it may not be suitable for a master's dissertation, but it is for a PhD dissertation or a bigger thing. So really plan your time wisely going into a visual social media project, because even if you're doing a close analysis of 3 images, that could wipe away months of your life if you let it. So how do you, effective time planning is a really good one. So some conclusions. I think there's a lot of flashpoints in terms of visual social media data, and I kind of have labeled this in the keynote as a crisis in crisis data, but it goes far beyond crisis data. I think one of the things I've felt in visual social media research is being under the pinch with the deluge of data, right? Like where do you set your boundaries? There's so much, like it's one thing with the tweets and running it through some sort of text mining, but it's another thing with visual data. You can get quickly inundated. And I think a lot of people, especially dealing with this sort of communication research, often feel overwhelmed by the amount of skills. So one thing I really want to say, and a venue like this is really good, is don't be. There's people who have gone through feeling frustrated and everything. Just be confident, learn the skills you need, think strategically in terms of time management, what skills you need. Learn a variety of methods, and then be prudent in terms of what you deploy. But you can definitely get through that. Don't feel like you have to be overwhelmed. And I think the social sciences and humanities tend to lack the technical capital, the technical resources. We often don't have the right equipment. We don't necessarily have access to fast computers, so our laptops start croaking if we want to run a bunch of images through classification systems. So the last thing I want to leave you with without being kind of a negative ending is I really have felt in my journey that using mixed methods is really a silver lining. So mixed methods have been the way I've been able to effectively deal with social media data, effectively dealt with algorithmic bias, effectively dealt with gaps in the data, effectively dealt with huge samples of data. Because if I start getting big data, I can use computational methods, but then I hit a wall with computational methods because it's only saying so much. Then I can bounce back, take a random sample, do some human coding, and find stuff like that American Apparel ad. Or another thing we found is actually how important pets are during a disaster. That actually dogs and cats really help people recover after disaster. So many people would insta their dog and be like, without my pet Harold, I would have never made it through Sandy, right? Like you see a lot of that. Those are themes I wouldn't have found, but kind of pinging back in these ways, I think visual social media research is a hugely fascinating area. I hope you guys have found the keynote interesting in that way and get inspired to think more. The end. All right. I don't know if we have any other time for questions or anything.
Thank you for the presentation. It was really nice. I was wondering one thing, and basically it's if you've bumped into this kind of questioning when working with images the way you've been working with, because even when we're talking about manual coding, although it can be more precise in some cases, and of course you can work with categories that are not pre-built into any of those tools. It's still kind of the same working logic, right? And we're trying to categorize and to do that. And one thing that I've found, and that's because I come from a background in which, image theory and also like theory of photography, in which some of that
You've got
kind
those
of
skills
approach,
I don't have. Yeah.
Okay, yeah. So I mean, it's something that I don't know. I just share this kind of problem that I know I'm bumping into with some scholars in the field, and then maybe you've found that as well, because one of the things that when you work with photography and the semiotics of photography, it's usually really deals with the idea of the individual element present on the image, right? Because it's not a general concept. It's an actual person or an actual situation.
Yep.
And then that's one thing that this kind of approach that I'm working with as well, we don't really have access to that.
Yeah.
Right?
I mean, you can't deploy kind of classic semiotics with this. A sort of Roland Barthes semiotic classification isn't going to happen, right? So that's one of the challenges with this sort of thing. So I mean, it's one where you kind of have to make, I think, the trade-offs and figure out what's going to work for you, I guess.
Yeah, because especially when we're dealing with this kind of dramatic situations, such as disasters, sometimes this happens to appear, right? It's like, even if, I mean, when you're having this kind of far reading of images, you sometimes are not, we don't really reach to the point of how images are actually read by humans. And that's one thing, like, because when we're comparing, like, a way, like, putting a human in the loop or taking it out of the loop. But then at the same time, we're all still working with the same kind of logic of categorization, which is not really how we humans look at images normally. And that creates some kind of paradox in which, this kind of comparison sometimes doesn't work. That's one thing that I'm crossing my mind.
Yeah, no, I mean, I agree with you. I don't think I necessarily have a solution here in any way. I don't think I'd love to be able to say there's this wonderful synergy between computers and humans, and I mean there isn't. We just find particular synergistic overlaps that emerge and try to exploit them. All I can say is, my work has highlighted that they do happen, but it's about being seriously patient and waiting for serendipitous occurrences. And being open-minded, because it could be, honestly, that you do use semiotics in that first fieldwork pass. There's nothing to stop you from doing that. So my approach is all about kind of mixing things. So maybe you do take 3 images or 2 images and do some close semiotic readings, and then through your exegesis, come up with some conceptual understandings that then you operationalize into some sort of axial coding scheme, and then look at more images. And then you deploy that to some sort of closed coding system that leverages Google Cloud Vision. So for example, let's say you come up with 5 or 6 closed categories that came from this semiotic reading that went to then some sort of axial coding, and then you throw it to Google Vision to go through 1 million images and return all the images that have some of these, like, 20 keywords that you come up with. That, it's a synergy. It also uses this approach of being iterative, of being mixed, of being opened, of trying to do that. So I guess I'm saying, it's up to you to find those intersections. But I think those intersections are what are going to be at the most cutting edge of visual research, rather than only doing one method. The only method is also good, but I think we're going to hit problems of scale then. So I'm trying to find ways to kind of marry or intersect these ways so I can scale up. Or I can go the other way too, where I'm just dealing with big data and then I bring it to small data. But generally on social media, we're going to have big N numbers at some point. So how do we deal with that? I would love to just be able to sit with a couple of images and spend a lot of time, but I just can't do that.
Yeah, that's a problem. Thanks.
Thank you.